coupling is a very small idea. So what is this? This is a rod. There are two rods are there. AB and BC, there are two rods are there. And BC is a joint, disconnected. And the C is connected to the gear. So there's like, you can treat like a circular disc it is. And there's a fixed gear. So now as the as I rotate the rod AB with angle velocity omega, what is the velocity of center of mass, center of the gear at the instant shown? At that instant is telling. So we have to look at this one. What is the velocity of the point? What is the angular velocity of this, of the rod AB? It is equal to 6 radians per second. So what is the velocity of center of the gear is asking. This is the gear. Huh? I think somewhere nearby diagram. Let me write. This is gear. Okay, I'll go for the rough diagram. Meanwhile, you try it. I'll finish off a rough diagram. So, like, can they ask such thing in JEE Advanced as possibility? Yeah? There's not a big concept. It's not a something very complicated things are there. Let this be a fixed one. So this particular rod, it is connected here. And again here a joint. No, so this is the A, B, and this is C. So this angular velocity is how much? 6 radians. We know this one. So what is the angular velocity of the point B? As a linear velocity of point B. It should be VB. So this angle is what? 60 degrees. Let me take this angle is 60 degrees here. If this is 60 degrees, can be this, will resolve this. So this will be 30. This should be the 60, no? The angle is 60 and this omega. This is 60, so therefore this should be 60 degrees. Or define this 30 degrees. Now first, what is the speed of the point B? Should be equal to, call this distance as R1 and let me call this distance as R2. AB equal to R1. And just I picked up a problem so that you'll get a confidence. Whatever the type of problem you can manage it. So what is VB equal to? Let's get into calculation part. VB should be equal to AB into omega. And what is the value of AB? 0.R1 omega. So this will be 2.46 into 2.4 meter per second. Now look at this. Both AB and BC, they are rods. They're rods. Basically what happened? They're rods. Well, as it rotates, what will happen to the length of the rod? Will it increase or decrease? Nothing, no? It remains same. So what should be the velocity of the ends along the rod? Should be equal. So VB cos theta should be equal to VC cos 60. Simplest approach. Nothing to do. So how the velocity of points? I'm going to say that it will be towards right only. So velocity of VB cos 30 degrees should be equal to VC. VB cos 30 degree. VB is how much? 2.4 cos 30 root 3 by 2 equal to VC. So VC is equal to how much? 1.2 root 3 meter per second. So this is the velocity of point C. And then as it is pure rolling, it must have rolling. So velocity of point 2, it will also rotate omega O and this one. So therefore, what should be the velocity of let me use some other thing. Velocity of point 2. What should be the velocity of point 2? And this point is a fixed, no, where it will roll. So here this is a fixed here. So here V naught should be equal to radius of this here is given R. V naught is equal to R omega naught. So, but he has not said anything. In fact, it will be rolling. The velocity of this point, this particular gear will have a rolling. The velocity of this point P, you can write it. Velocity of point P must be 0. And V naught minus R omega naught. Okay, now we is asking V naught, no? As it is a pure rolling, so what is the velocity of point C should be V naught plus R omega naught. And V naught equal to R omega naught. So therefore V naught and V naught. So this will be 2 V naught. So what is the velocity of point 2? Vc by 2. What is Vc value? We know this one. So 1.2 root 3 by 2. Just motion of connecting bodies, nothing big. It's a motion of the connecting bodies here. Now, there's a one way of doing problem. The same problem you can do by instantaneous center also. Okay, sir, we got answer. What is the use of instantaneous center? Look at the BC. So here shall we put like this? Is it rod BC just moving or rotating? In fact, rotating. So here I will velocity of point B in what direction? In direction perpendicular to that R bar will come. And perpendicular to VC, what will happen? I should draw a position vector where those 2 points intersect. That will be the center about which the rod BC is rotating. I'll also ask you what is the angular velocity of the rod BC. So immediately what happens? You are supposed to take help of this condition. So this you call Y, this you call small r. But we don't know all these things. We know rod BC and we know this angle. This angle should be how much? 60 degrees. Can you find out R? Yes, what is cos 60 degrees? I can ask you, I'll trouble you with such questions. What is the angular velocity of the rod BC? Yes, we can find out here. Now cos 60 is equal to BC by R. We know length BC, 0.6 meter. Then I'll get the VB. So what is VB is equal to R into omega BC. I know R, then I know VB, then I'll get omega BC. If I know omega BC, I can write again BC. If I know VC, I'll bring it. So in fact, the rod B is rotating. Both rods AB and BC are rotating. Rod AB rotates about A. Rod BC will not rotate about B or about C. It will rotate about, say, some point D. I think I'll give nice better information so that it will be a confusion will not be there. Rod AB rotates about A. Rod BC rotates about point D. So shall we say this is the instantaneous center for this rod? Rod AB rotates about point A. Rod BC rotates about point D. And the point D will become instantaneous center at that instant. At that instant, I'm saying. Several approaches. So whenever rod comes, okay, keep that idea. What is the reason for this? What is the reason to write this? Any reason you should write length of the rod? Length of the rod BC remains same. Is it okay? Fine. Nothing to do. No concept. Nothing. And sir, how you can say about point it will rotate? I'll go back to circular motion. V equal to R omega, and how R should be perpendicular to V bar. That's what the basic definition. No? R is the position vector. So I know VB bar. Perpendicular that I'll write position vector. I got BD bar. This is R bar. Then I know velocity of this end of the VC. Then perpendicular that I'll get where those two intersect. There's the instant center. Rod BC in fact rotating. That's what I mean to say. I'll give a few more examples so that you'll get an exact picture. I'll give a few more examples.